Okay, today I'm going to go over lesson 5.2.2, writing equations for arithmetic sequences. So first what we got to do is we need to review a little bit of what we talked about already. So what is an arithmetic sequence? We also got to talk about geometric to remember that. So I got a few examples over here on the right-hand side. Remember, an arithmetic sequence is where the sequence generator, or whatever is being changed by each number, okay, is always adding, or some people also say subtraction as well. So as you can see on A, it is adding 2.75 every single time. Okay, so every single time you're plussing 2.75 on A. And on B, you are minusing 8, or adding a negative 8 is another way of saying it. Okay, so those are arithmetic sequences when you're adding or subtracting from each term. Sorry, my dog's gonna want to play with this toy now. But we also, so when I say term though, so we need to review this. Okay, term is represented by T of n when we talk about sequences. Okay, so 2.25 is a term. 5 was the next term. The term after 5 was 7.75. Then we had 10.5 for A. So this is all for sequence A here. Okay, that is what term means right here. And I also have the definition right here. It's a number in the sequence in a certain position. Okay, now term number is represented by that n. And that's what we just say, friends. So that tells you the position that you're looking at in the sequence. So 2.25 is the very first number listed in our sequence. So that term number is 1. 5 is the second number listed in our sequence. So that one is term number 2. And then 7.75 is 3. 10.5 is 4. And then the next one would be 5, 6, 7, so on and so on. So term number is always going to be a positive integer, okay? It's always going to be the positive integer. And I'll write that here as well. All right? The term is what is in that spot, okay? So that's what we would, if we were to keep our list going for our sequence, or keep our sequence going, we were to find the next number in there, the next term in there, that we just, that's what our term, that's our T of n, okay? So now, we've got to refresh also for geometric sequence. Remember, geometric sequence is where we are multiplying or timesing each term by something, or each term. So for this one, it would be times by a negative 4. It would times by a negative 4, times by a negative 4. In D, it is, some people like to say dividing by 4, but instead of saying dividing by, we should say multiply by the reciprocal, or multiply by 1/4. Okay, multiply by 1/4, okay? So those are geometric sequences. So our geometric is multiplication. Some people also like to say division, but we always want to say multiply by a reciprocal. An arithmetic sequence is always addition, and then you can also get it with subtraction on that one. Okay, but today we're going to focus on arithmetic sequence, and we're going to be focusing in onto term number and term. So term number, remember, is the spot you're in, and the term is what is actually in that spot. So term number is going to be represented with n, and term is going to be represented with T of n. All right, so here we go. Starting off with 5-56 here. We're going to be looking at this one. Oops, I'm moving everything. I'm going to go ahead and erase that. Sorry, I'm having some trouble with my screen right now. All right, so here we go. This is 5-56. So we're going to consider the following sequence here, and I'll highlight it here for us. Okay, our sequence is -9, -5, -1, 3, and 7. What I want you to do first now is I want you to just to look at letter A, okay? And I want you to determine if the sequence is arithmetic, geometric, or neither, and how can you tell? So I want you to answer that question, pause the video and answer that question. All right, so after looking at this one, you should have noticed here that going from each term, okay, to the next term is plussing 4. Okay, so I'm plussing 4 each time. Okay, so that's how we can tell, which tells us it is going to be arithmetic. Okay, because arithmetic, way to remember it is arithmetic starts with an A, so that means add. So it's arithmetic. So that's what our sequence is going to be. Okay, now I want you to answer question B. What is the first term of the sequence? So remember, the term means what would be the first number listed. Okay, what's in spot number 1? So go ahead and pause the video and answer this question. All right. So I kind of gave a big hint away, but it's saying what is the first term in the sequence? Okay, that means our first term is term number 1. So we're looking in the first spot here, which is oops, I don't want the highlighter, which is a -9. So -9 is the first term listed in this sequence. Okay. Now, what I want you to do, I want you to answer question C. What is the common difference? Oh, I have spelling here. What is the common difference? See, that should be A, C, and E. Okay, what is the common difference? Okay, which means the number being added to get to the next term. So I want you to answer that question now, please. All right. So as it might have been mentioned in a previous video, we were used to talk about sequence generator. This is the word that we change it with when we're talking about arithmetic sequences. The common difference is the number being added each time, which in our case is +4. So the 4, a positive 4, is what our common difference is for this question. All right. Okay, so now we're going to use this sequence. So I'm going to write it down here below. Okay, and we're going to write an equation for this one. So this one you just have to watch now. So we have -9, -5, -1, 3, and I think there was a 7 listed. Okay, and then dot, dot, dot. So we need to write the equation for the nth term. That means this is going to be an equation, and it's going to be for any generic one. So we could find for any term, okay, or any term number. If we knew a term number, we could determine what the term would be in that spot. Here, what number is in that spot? So what we need to do here to do this is, since it's arithmetic, it means we're adding each time, okay? And what this kind of goes by is it goes by a linear model, okay? And as we kind of discovered in doing the last step is where arithmetic is going to be linear, which means it's going to follow that idea of y equals mx plus b, okay? Y equals mx plus b is what it's going to follow. Now, with that, though, what we're going to do here is y was always the output, or what came out. That is going to be our t of n, okay? That's going to be the term. That's going to be the term that we get, okay? And then our m is going to be our common difference. So common difference, I'm going to put that here, difference. Okay, our x is then, so we're going to take that common difference times our x, which is now going to be our n. That is going to be our term number. And that plus b is now going to be our t of 0, which means we have to find the 0 term in the sequence. Okay, so we have to find the 0 term. So if we're trying to write this equation for this arithmetic sequence here, we're going to start off by saying t of n, okay, because that's just where it's going to be a generic equation. So instead of a y, we're going to say t of n, which is that function notation that we've used, okay? And then we're going to say equals our common difference. Well, our common difference we found before was a +4. So we're going to say 4 times n. Well, that's just going to be n because we don't know what n value we want or what term number we want. So we're just going to leave n in there, plus t of 0. So that's what we have to find now. So to find t of 0, you first need to locate what is your first term in the sequence. Well, we already did that above. We said this was our t. This would be -9 was our first term in our sequence, which means that's our t of 1. Okay, and as we continue through here, t of 2 is the second term. Okay, or when n is 2, we get -5. As when we can do this with a chart as well. Okay, 1 would be -9, 2 would be -5, 3 would be -1. Okay, but we want 0. And we know we were adding 4 each time to get to the next term. Well, now we got to go backwards here to get to our 0 term, or our t of 0. So going backwards, we got to do the opposite of plusing 4, which means we need to minus 4. So we need to do -9 minus 4, which gets us -13. This number now is our t of 0. That means that is going to be the n part of our equation. So we're going to say 4n minus 13. Okay? And there would be, oops, I don't want that. There would be our entire equation then. This t of n equals 4n minus 13. That would allow us to find any term in the sequence. Okay? That would allow us to find any term in the sequence. All right, so here we go. Let's go to another example here. Scroll my screen here. All right. So what I want you to do here first is I just want you to answer question A. What is the common difference right now? What is the common difference? So go ahead and answer that question. Okay. So your common difference, remember that's telling you this has got to be arithmetic, by the way. Okay. But you should see in the sequence here, -4 to -1 is +3. -1 to 2 is +3. 2 to 5 is +3. And I should have ... here as well. So our common difference is adding 3 each time. Okay. Now, I want you to answer question B. If the first term is t of 1, I want you to find t of 0. So find the 0 term. So go ahead and pause the video and complete that question. All right. So here we go. I'm going to make a little chart here to help us out with this one. So if n and t of n, okay, so we're trying to figure out what is when n is 0. Okay, and we already know we know 1, 2, 3, and so on and so forth. Because the term number, you can't be in the middle of a spot there. Like you can't be at 0.5 spot. That's just not possible for a sequence. Okay, otherwise our sequence or common difference when it stay the same. But we know the first term in our sequence is -4. Our second term was -1. Our third term was 2. The fourth term was 5. And we know we were plussing 3 every single time to get down to these next terms. So that's how we're getting to our next term. Now, we're going to go backwards, though, to go from 1 to 0, which means we got to go do the opposite of plussing 3 to go backwards. So I have to -3. So -4 minus 3 is -7. So t of 0 equals -7 in this case. So our 0 term is -7. Okay. Now, I want you to try and write the equation for t of n. So remember, it's going to be very similar to y equals mx plus b, but we're going to have different things in those spots. So I want you to try and write the equation now. All right. So remember, it starts off with t of n. Okay, that's like where our y was. Okay, that tells us it's a sequence. We use t of n for sequences. Okay, remember, it's just function notation, and we like to stick with t and n. Okay, n is the term number. It tells us the spot we're in. Okay, then comes the common difference. That would be like our slope. Okay, that's what's changing by each time. It's at a constant rate. So then that's a +3. Then we're going to have our n value. So we're going to have 3 times n. And then we're going to put in our plus t of 0, which in this case is a -7. So I'm just going to say -7 here. I don't have to say plus a -7. I'm just going to say -7. It's the same thing. So our sequence, or the equation for this sequence above, is t of n equals 3n minus 7. Okay. All right, so we're going to use this equation now, and we're going to answer a couple of questions here. Okay, so I'm going to write the equation above. So we have t of n equals 3n minus 7. Okay, the first question I want us to answer is what is the 16th term? Okay, what is the 16th term? Which that means we're looking for what number is in the 16th spot, which means 16 is our n value. That's what's going to go in for our n. So we know the term number in this case is 16. We're trying to figure out what is the term going to be. Okay, what is the term going to be? So when we do this one, we're going to say t of 16 equals 3 times, well, I put 16 in for my n. So I'm just going to do 3 times 16 minus 7. Okay. So we're going to have t of 16. Remember, that's just function notation. We're just going to leave it there. That's fine. Function notation just tells us that in the 16th spot, our output or our term number is going to be this, whatever we get. 3 times 16 is 48 minus 7. Just got to finish here. We're then going to have t of 16 equals 41. Okay? So our term is 41. That's what is in the 16th spot, or when our n is 16, our term number is 16. So what is the 16th term? Well, that's 41. Okay, and I just left it in function notation here to tell us that. Okay, the term number was 16, and the term was 41. All right, so here's the last question I got for this problem here. Okay, I'm going to erase this so I have a little more room. We're going to answer this last one right here. I'm going to put a blue star next to it. Is 42 a term in the sequence? All right, so what this means is it's telling us 42 is a term. That's what it's telling us. It's telling us, is that a term? Well, remember, if this thing is that a term, that is t of n. So 42 would replace t of n in the equation. So we're trying to figure out, is it a term? So that means, is there a term number that would have this in that spot? So just take your equation and replace t of n with 42. So we would say 42 equals 3n. We don't know what n is. Okay, that's what we're trying to find out. Is 42 going to be in a spot where it's in a term number spot? So 3 of n minus 7. So now you just solve this equation right here. 42 equals 3n minus 7. Well, remember the first thing you got to do is plus 7 to both sides. So you get 49 equals 3n. Okay. Then to get n by itself, you divide by 3, divide by 3. So n equals, let's see here, that's going to be 16.3 repeating. Okay, you can just type that in a calculator. Now, here's the question. Can we have a term, can we be in spot number 16.3 repeating in a sequence? Well, when we made our table, think about this, when we made our table, our n values, okay, we're going by 1, 2, 3, 4, 5, and so on. They're always going up by ones. So our spot numbers were always just increasing by 1. So can we ever have a spot be a 0.3, be a decimal? You should be like, no, we can't have this happen. Okay? So what we say here is 42 cannot be a term. Okay? So 42 is not, I'm trying to spell it, not a term. That is our answer here. Okay, 42 is not a term. All right, so don't worry. I didn't leave you hanging. You're going to have one to try out yourself now. Okay, so this one is from the problem that we started with, the very first problem, which our equation was t of n equals, double check, make sure I write it correctly, 4n minus 13. Okay, 4n minus 13. What I want you to do is just start with the first one here. I want you to figure out what is the 51st term. Let's say 51st, not 51st. 51st term. Okay, so that means we're trying to figure out what would be in spot number 51. I want you to go ahead and try this one out. If you get stuck, go ahead and resume the video, or once you get an answer, resume the video. All right, so since we're looking for what is in spot number 51, that means this is going to be our n. That's what 51 is going to be in the spot of. So we're going to take our equation, we're going to say t of 51. It just replaces the n. So t of 51 equals 4 times 51 minus 13. Okay. So t of 51 just never changes. It's just that notation. Okay, that's okay. So t of 51 equals, well, 4 times 51 is 204. Okay. And then we have our minus 13. Okay, so I'm just going to leave t of 51 there. 204 minus 13 is 191. Okay, 191. So that means in the 51st spot, we get 191. That is the term in the 51st spot, or in the term at term number 51, we have our term is 191. Okay. All right. So now I want you to answer the second question here. Is 235 a term? Okay. Is 235 a term? So go ahead and answer this one. If you get stuck or you got an answer, go ahead and resume the video. Okay, so since it's asking, is 235 a term? That means 235 is going to be t of n. So it's going to replace t of n now instead of just n. So we know what the term is, and we're trying to figure out if it actually happens. If we were to continue counting in our sequence, would we ever get to 235? So I'm going to put 235 in for my t of n. So I'm going to have 235, that's on the left-hand side, equals 4n minus 13. Okay? And then we just have to solve. And remember, we're hoping n is an integer. mean it's a positive integer, so it's got to be 1, 2, 3, 4, 5, 6, 7. It's counting it by ones. It cannot have a decimal. Okay? We don't want it to be a negative either because we can't have a term number be negative. We always start at 1 in our sequence. So I'm going to add 13 to both sides to solve this. Okay, add 13. I get 248 equals 4n. Then I'm going to divide by 4 on both sides. So I get n equals, see, 24, that's 62. Oh, that's an integer, and that's even, or not even, it's positive and it's an integer. We have no decimals. So yes, our answer is yes. 235 is a term, okay? 235 is a term, all right? Okay, so continue to practice these. If you have any questions, please let me know. Have a great rest of your day.